Okay, now we have question 3 to solve. An insurance company has collected the following data on the gender and marital status of 300 customers. Right, the gender being male and female, and customers being single, married, and divorced. Okay, so let's come to the table given. We realize that for the single, there are 25 males and 50 females. For the married, there are 125. For the single, there are 25 females, 25 males and 50 females. For the married, there are 125 married men and 50 married females. The divorced, there are 30 male and 20 females. Right. Meaning that for the total number of singles, it is 25 plus 50. So let's come to change this. So for the number of singles, we have 75. Okay. The number of married people is 125 plus 50. So it's going to be 175. It doesn't matter whether male or female. As long as they are married, they will fall under this category. For divorce, 20 and 30 will be 50. Right, so there are 75 singles, 175 married, and 50 divorced. Let's talk about the male role now. There are two roles, the male and the female. For the male, we have 25 singles, 125 married, and 30 divorced. So adding this to this is 150 plus 30, 180. So in total, we have 180 males. Let's come to the females. 50 plus 50 is 100 plus 20, 120. So 120. So in total, we have 180 males, 120 females, singles 75, married 175, divorce 50. When you add this to this, you get 300. The same applies when you add 75 to 125 to 50, you get 300. So this 300 is the sum of all the people, all the customers under the insurance policy. Hope you understand. Okay. Now, the first question is, suppose that a customer is selected as random. Develop the joint probability table. Develop a table for the probability. These are the number of customers, but let's use probability to draw another table. Okay, the total sample space is 300, but this is 25, 125, 30, 50, 50, 20. So for you to develop this table, it's supposed to be this 25 over 300 will come to this section. So for the single, between single and male is 25 over 300, which gives you 0.8333. So 0. Let me use a black. Yeah, 0.0, sorry, 0.083 to 3 decimal places. Right. Let's come to married men. So the relation between male and married is going to be 125 over 300, which gives us 0.417. Now we come to divorce and male. That's going to be 30 over 300. That's going to be 0.100. Now I come to female and single. That will be this portion. So it's going to be 50 over this 300, and that will be 0.167. I said 3 decimal places. Now female and married will be this intersection. So female and married. this intercept is going to be 50 over 300, which is 0.167. Then come to female and divorce, this portion, which is female and divorce, 20 over 300, which will give us 0.06. 0.06. Now this is our developed joint probability table, right? You can add this to this to get the total sum of the singles. You can add this to this to get the total sum of the married. You can add this to this to get the total sum of the divorced customers. When you add this to this to this, you get total males. When you add 0.167 to 0.167 to 0.06, you get total females, right? So now we are done with A. We have developed our joint probability table. Let's come to the questions. So 2. Find the probability that the customer selected is a married female, right? Find the probability that it's a married female. This is not a conditional, just straightforward, married female. So probability of married, let me use MAR for married, intersection female, if married and female. So intersection female and married is what? 0.167. You get it? It says find the probability that the customer selected is married female. This is not conditional, straightforward, married female. When you see if, that's conditional, but this is married female. So females are here, married are here. So this is the intersection, 0.167. So 0.167. Let's come to question 3. Find the probability that the customer selected is female and single. This is also not conditional, but there's no if. It says female and single. So females, then single. It is this value. So probability female intersection single equals to 0.167. That is the A. Let's come to B. Married if the customer is male. This is conditional. So the problem reads, find the probability that the customer is married if customer is male. So if customer is male is the condition given. So we are finding probability of married given that the customer is male. That's the meaning of it. Find the probability of the person being married given that the person is a male. So this is probability of married intersection male all over probability of male. You know this formula. So you come here. So now let's find the intersection between the married and the male. So let's come here. This is my male, this is my male, and this is my married. This is the intersection, 0.416. So I write 417 over probability of male, meaning sum of all the male. This is probability of male, the value here, and this is going to be 0. Sorry, 0.083 plus 0.417 plus 0.100, and it's going to be 0.6. So 0.417 divided by Right. 0.417 divided by 0.6 will give us 0.695. So we are done with. Now let's come to, let me put my C here. C. Find the probability that the customer is not single. Right. So let's check the probability of getting a single. This is single column, married column, divorce column. This is male row, female row. So single means it could be male or female. So you add this to this. So probability of single is equal to 0.0.083 plus 0.167, which is 0.25. This is probability of single. By saying probability of not single, meaning you are finding the complement. So this is what you are finding, complement. And you know that the complement of this is the same as writing 1 minus probability of single. So if your probability of single to be 0.25, its complement is going to be 1 minus that value, which is going to be 0. Let me write it well for you. 0 to be 1 minus
Good morning, sir.
0.25, which is equal to 0.75. So we have here, this is the whole question. We're given a table, right? 300 people, 300 customers. We have a single column, married column, and divorce column, male row and female rows, right? Total number of males is 180. Total number of females is 120. Total number of singles is 75. Total number of married people is 175. Total number of divorced customers is 50. It's saying develop joint probability table. But we know that the total number of customers is 300. So for this position, you have to find 25 over 300, write it here. 125 over 300, write it here. 30 over 300, write it here. 50 over 300, write it here. 50 over 300, write it here. 20 over this 300, you write it here. So we're done with developing the joint probability table. Let's come to the second question. Find the probability that the customer selected is a married female. This is straightforward. Married and female. The intersection of married and female, which is this 0.167. So probability of married and female 0.167. Question 3. Find the probability that the customer selected is female and single, intersection female and single. So 0.167, exactly that, female and single. Let's come to B. Married if the customer is male. This is conditional. So we are finding probability of married. So probability of married if, given that if the person is male. So it's going to be probability of this intersection, this, so married intersection male all over probability of the second one male. So probability of married intersection male is, we have here male and married. This intersection 0.417. So it's 0.417. Probability of male. So you know the probability of male is going to be the male row add everything together. This is probability of male, this is probability of female. So you add everything. 0.083 plus 0.417 plus 0.1, which gives us 0.6. And 0.417 over 0.6 is 0.695. Now let's come to C. Find a probability that a problem selected is not single, right? Not single, meaning complement of single. But we know that we can find probability of single. This is the single column. This is the single column. So when I add this to this, so it could be single male or single female. When I add them together, I'll get probability of single, which gave me 0.25. So 0.083 plus 0.167 gave me 0.25. Now the probability of single complement is equal to 1 minus p into bracket s, which means 1 minus probability of single. So not single is the same as saying 1 minus single, which gave me, sorry, which gave me 1 minus 0.025, and I have 0.75. So this how to solve this question.